Hello friends, welcome to my YouTube channel. Today we will discuss PYQ question from Machine Learning Foundation. It was asked in May term 2023. So the first question is, which of the following are supervised learning tasks? So this is a MCQ question, multiple select question, and here are first option is predicting future weather condition based on past weather observation, and second is reducing the dimensionality of images with while retaining essential features enabling efficient storage and transmission. And third is identifying objects in images with multiple categories such as cats, dogs, cars, and trees. And fourth option is categorizing news articles into topics like politics, sports, entertainment, and technology. So the solution of this problem is, as you know, supervised learning tasks involve learning a function that maps input data to output data based on example input output pairs. So here are solution of each task. So what is first is predicting future weather conditions based on past weather observation. So this is a typical supervised learning task, because you can train a model using past weather observations as input and corresponding future weather conditions as output. So this is a supervised learning task. First is supervised learning task, and second is reducing the dimensionality of images while retaining essential features and enabling efficient storage and transmission. So this is a typically an unsupervised learning task, as it involves finding patterns or structures in the data without explicit supervision. Techniques like principal component analysis, called PCA. You will study this in your MLT course, in upcoming MLT course. Or autoencoders are commonly used for dimensionality reduction, and they don't require label data. So this is a typically an unsupervised learning. So this is not a supervised learning. And third is identifying objects in images with multiple categories such as cats, dogs, cars, and trees. So this is typical supervised learning tasks, known as a image classification. You can train a model using labeled images, where each image is associated with a category like cat, dog, car, tree, to learn to identify objects in new images. So this is also a supervised learning task. And fourth is categorizing news articles into topics like politics, sports, entertainment, and technology. So this is another example of supervised learning task. You can use a labeled news article where each article is associated with a topic, politics, sports, entertainment, technology, to train a model to categorize new article into these topics. So the first, third, and fourth are supervised learning tasks. Okay, and proceeding with the next problem. In the next problem, here is one table given, input output pairs, and we have asked which among the following models has the least misclassification error. There are 4 options given, and we have to select in these options we have to select with least misclassification error. So the for classification model, algorithm model outputs a model from d-dimensional space uh, to plus or minus 1. It's like binary type. Output would be either plus 1 or minus 1. So the the formula for calculating a loss for such type of classification, 1 by n sigma summation from 1 is equal to 1 to n, and this is like a boolean expression, where if fxi does not equal to yi, then we will consider this plus 1. Okay, so you can understand this formula better in an example while solving the problem. So I will explain what is the process to calculate the loss. So if there is input 0, 1, and it is given y is equal to plus 1, plus 1, plus 1, and for remaining 3 it is minus 1, minus 1, minus 1. So consider first option. If we consider first option, sign x1 minus 2, so the what sign will result, either it will result plus 1 or minus 1. If the value of the function is positive, then it will result plus 1, and if the value of the function is negative, then it will result minus 1. So in case of x 0, 1, this is a function. Inside this function there is written x1 minus 2, so the x1 value, this is a x1 and this is a x2. We will assume this is x1 and this is x2. So the x1 minus 2, so 0 minus 2 is negative, so it will result minus 1. For this 0 minus 2, so minus 1. For 1, for this x1 is equal to 1, so the 1 minus 2 is equal to minus 1, so that it is also negative, so result will be minus 1. For this 3 minus 2, result is plus 1, so the it is positive, so the answer will be plus 1. For this 4 minus 2, 2, it is positive, so it will be plus 1. For 7 minus 2, 5 plus 5, so the function value is plus 1. Similarly, for remaining 3 options you can calculate. Okay, so if we have to find loss for these 4 functions, so to calculate the loss we will use this formula. If fxi does not equal to yi, we will consider this as boolean value 1. So where it is not equal to, so in case of y is equal to plus 1, but this is a minus 1, so we will consider this 1. We will consider this. Okay, let me remove this and we will tick which value we will consider. Okay, so the plus 1, it is minus 1, we will consider this because it is not equal to value of the function. Y value is not equal to y, so we will consider this. And for this is also deviating from the output, so it will be also considered. This is also deviating from the output, we will consider this. This is also deviating from the output, we will consider this. We will consider this minus 1 plus 1, so minus 1 plus 1, we will also consider this. So we will consider all 6 input data. So it will be result because it is deviating from the, our actual output. So the loss will be 1, 2, 3, 4, 5, 6. So 6 by 6 by the values of input data. So 6 by 6 equal to 1. So the for first the loss, the value of loss is 1. Similarly, if we calculate this, we will it is not deviating from there, so we will not consider this as a loss. This is not deviation, we will not consider this as a loss because it is all exactly matching with our actual output. So it is also, we will consider this will deviate from our actual output, so we will consider this. We will also consider this, we will also consider this, and so the the value of loss will be we will count where it is deviating from our actual output. So 1, 2, 3, so 3 by 6 is equal to half, 0.5. So for second option, for this value loss function is 1. For this the loss function is 0.5. Okay, for third option, similarly for third option we will calculate loss. This is deviation, this is not deviation, this is not deviating from our actual output, this is also not deviating, this deviating. Okay, we will consider this is also deviating, this is also deviating. So 3 input data are deviating from actual output, so 3 by 6 is equal to 1 by 2. So the loss for third option is also 0.5. Okay, similarly for fourth loss is equal to 2 by 6 because there are only 2 outputs which are deviating from our actual output, so which was this and this. All other are exactly matching with our actual output. So in this case 2 by 6 or 1 by 3, which is equal to 0.33. So 0.33. So we have to calculate which model has the least misclassification error. So the fourth option has least loss and least misclassification error. So this is all other options are incorrect, only this is correct. Okay, so let us proceed with the next problem. Problem number 3. Consider a vector v 2 1 minus 2. Does v belong to the column space of A? So we have to calculate, we have to find out whether this belong or not. So either it will be yes or no. So we have to find, to determine if the vector v belongs to the column space of matrix A, we need to check if v can be represented as a linear combination of the columns of A. So let us write down the augmented matrix first and reduce into row echelon form. So we will write this minus 8 minus 2 minus 6 4 8 404 404, and this is our vector v 2 1 minus 2. This is a augmented form of matrix A B. Okay, and perform row operations to get it to row echelon form. So the row echelon form is this. You can also you can calculate this, and this is our actual row echelon form. Process to convert in row echelon form is this. You can find out this and divide row 1 by minus 8. We have performed operation on matrix. Then subtract row 1 multiplied by 6 from row 2. So we will got this. And then we will subtract row 1 multiplied by 4 from row 3. So we will get this. Then multiply row 2 by 2 by 5. We will get this. And then subtract row 2 multiplied by 1 by 4 from row 1. So we will get this. Finally add row 2 to row 3. We will got this. Okay, this is our final reduced row echelon form of the matrix. And now we see that the last row the last row represents the equation 0 is equal to 0, which does not provide any new information. The system has a solution, and last row does not contradict the earlier rows, which means the system is consistent. You can find out the solution which is consistent. So there is no contradiction, and system is consistent. So V does belong to the column space of matrix. So the answer is yes. This vector V belong to column space of A. Okay. So let us proceed with the next problem. The next problem is let A is 2 cross 2 matrix, and find a matrix P such that P inverse AP is diagonal. So we have to find out the matrix P for such that P inverse AP is diagonal. So to find a matrix P such that P inverse AP is diagonal, we need to first find the eigenvectors and eigenvalues of a matrix. So first we will find out the eigenvalues, then we will calculate the eigenvectors. So first let us find the eigenvalues lambda by solving the characteristic equation, which is a determinant of A minus lambda I, where I is the identity matrix, and we will calculate the determinant, and this quadratic equation factors into lambda minus 5 and lambda minus 10. So this results into eigenvalues lambda 1 is equal to 5 and lambda is equal to 10. So next we will we find the eigenvectors corresponding to each eigenvalue. So for lambda 1 is equal to 5, we will got this. If you don't understand, this is a 8 minus 5 3 2 7 minus 5. So this will result into 3. Okay, 3 3 2 2 x y is equal to 0. So this equation gives 3x plus 3y is equal to 0 and 2x plus 2y is equal to 0, which simplifies to x minus y, x equal to minus y. So an eigenvector corresponding to lambda 1 is equal to 5 is a non-zero multiple of 1 minus 1. And similarly for lambda 2 is equal to 10, we will solve this. Minus 2 3 2 minus 3 x I 0 0. So this gives the equation minus 2x plus 3y is equal to 0 and 2x minus 3y is equal to 0. Minus 2x plus 3y is equal to 0. 2x minus 3y is equal to 0, which simplifies to x is equal to 3 by 2y. So an eigenvector corresponding to lambda 2 is equal to 10 is a non-zero multiple of 3 2. You can write this as x y. This is eigenvector, no? This is eigenvector x y. So we can write as x equal to 3 by 2y. So this is a 3 by 2y and this is y. We can again take y is common and 3 by 2 1, or you can simply multiply, take 2 as a common, and or multiply 2 with constant 2. If you multiply by 2, then or this is can be written as 3 inside of the matrix, so we'll got this. So this is a non-zero multiple of 3 2. So now we can construct matrix P with these eigenvectors as columns. So the 3 2 and 3 2, and for this 1 minus 1, so we will add this. So our final answer is 3 2 1 minus 1. So this is our correct answer. Okay, so let us proceed with the next problem. So the problem number 5 is consider a regression model x1 x2 is equal to x1 plus x2 by 2 for the below input data points, and the mean squared loss for of h, and enter the answer correct to 2 decimal places. So the mean squared loss for the given model fx is given by this formula. Okay, so for input 1 comma 2, there is y is equal to 2, for 2 3 3 3 comma 4, output is 4 4 comma 5 5. So we will calculate the value of function at these points, regression model function. So for regression model function, the value of hx is 3 by 2, and for this 5 by 2, for this 7 by 2, and for this 9 by 2. So we will calculate this y minus hx ka whole square, and y is equal to 2 and hx is 3 by 2. We will square this and get 1 by 4. Similarly we can calculate this. So therefore the last function for the function hx is 1 by 4 plus 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 1 by 4 divided by 4. So the answer is 4 by 16, which is equal to 0.25. So the final result is 0.25. So let us proceed with the next problem. So the next problem is the curve y is equal to x square plus bx plus c passes through the points 2 comma minus 1 and 0 comma 0, and is tangent to the plane y is equal to minus x at the origin, and we have to find the absolute value of the product AB. Enter the answer correct to 2 decimal places. So we will randomly draw the quadratic equation, the curve, and draw a tangent to the line y is equal to minus x at the origin. Okay, so this is equation of y is equal to minus x, okay, at 0 comma 0. So find out the linear approximation to the to the curve at the origin. So to calculate the linear approximation at the origin, we will use this formula. Linear approximation of x, value of the function, then plus f dash at a and x minus a. Okay, so we'll use this formula and calculate the linear approximation, which is equal to c plus bx, because at 0 comma 0 function value is c. So the value, and if we calculate f prime, so we will take derivative 2ax plus b. So if we calculate this derivative at 0 comma 0, so it will be b. So this is written here bx. So that is approximation is c plus bx, and we will call equation 1. Now since the curve passes through the points 0 comma 0 and 2 comma 1 is 1, it will satisfy the curve. So we will substitute the value of these points into curve and get c is equal to 0 and 4a plus 2b is equal to minus 1. Okay, so we will call this as equation 3rd, and substitute c is equal to 0, substitute c is equal to 0, we got this c is equal to 0 and into equation 1. This is linear approximation line, we will substitute this value c is equal to 0, we have got a linear approximation as x equal to bx. So now it is given that tangent to the line is y is equal to minus x at 0 comma 0. So by comparing both these two, this equation and y is equal to minus x, because this corresponds to the same tangent. This is a linear approximation, this is a exactly given line y is equal to minus x tangent to the line. So by comparing we can find the b as minus 1. Okay, so by putting b is equal to minus 1 into equation 3rd, this equation 3rd, we call it equation 3rd, into 3rd, we call 4a minus 2 is equal to minus 1. This corresponds to a is equal to 1 by 4, and we will find out the absolute value of product of ab. So we will find this 1 by 4 multiplied by minus 1. This will result 0.25. So our final answer is 0.25. Okay, so let us proceed with the next problem. So the problem number 7. So at the point p0 is equal to 1 comma 2, the function fx y has a derivative of 2 root 2 in the direction 1 by root 2 comma 1 by root 2, and a derivative of 5 in the direction 0 comma 1, and find the derivative of fxy at point p0 in the direction minus 1 by root 5 comma 2 by root 5. So what we have to find, so it is given to find the it is directional derivative, because it is a multivariable function fx comma. So in this case we will find gradient of fxy is given by del f x comma y, which is fx comma fy, or del f by del x comma del f by del y. So given at the point p0 1 comma 2, directional derivative is 2 root 2 in the direction 1 by root 2 comma 1 by root 2. So we will calculate directional derivative at this point p0. So assume at p0 the directional derivative is fx comma fy, this, and multiplied by unit vector. So the unit vector is already in the this is already unit vector, because if you take modulus it will be 1. So this is already a unit vector. So we will directly take dot product with fx comma fy, and it is and equated with 2 root 2, because it is given that directional derivative is 2 root 2 in the direction of unit vector. So we equated with 2 root 2 and calculated fx plus fy is equal to 4. This is equation first. Similarly, directional derivative is equal to, it is given 5 in the direction 0 comma 1 at same point. It is important because this is it is at the same point it is talking about this in the question, in this problem. So we will calculate this directional derivative is given as 5, and we will equate this with dot product of gradient of f with 0 comma 1, because it is given that, and 0 comma 1 is already it is a unit vector. 0 comma 1, if you take modulus of this vector, it will be 1. So this is already a unit vector. So we will take dot product and calculate fy is equal to 5. So by substituting fy is equal to 5 into equation 1, we can get fx equal to minus 1, and finally we have to find out the at p0 at same point. We are again talking about at the same point what is the derivative, directional derivative. Okay, so at the same point the directional derivative is del f dot product with unit vector, and minus a unit vector is minus 1 by root 5 comma 2 by root 5. This is again a unit vector. We don't need to convert this into a unit vector, because if we take modulus of this, we will get 1, because if you take a square root, this will be 1 by root, this is 1 by 5, and this is a 4 by 5, this is a 4 by 5. Okay, so the result will be 5 by 5. This is already unit vector, so I'll directly take dot product with minus 1 comma 5, and because and dot product with minus 1 by comma 5, and which is minus plus 1 by root 5 plus 10 by root 5, this is 11 by root 5. This is approximately equal to 4.91. Okay, so let us proceed with the next problem. Problem number 8. Consider a 2 cross 2 matrix A whose eigenvectors are this with eigenvalues 2 and 3 respectively. Find the sum of a square for all the entries of it. So it is given that eigenvectors are 1 1 and v2 is equal to 1 2 for lambda 1 is equal to 2, and this is for lambda 2 is equal to 3. So we will use definition of eigenvectors, which is equal to, if it a v1 is equal to lambda 1 v1. So let us suppose matrix is a b c d, assume. Okay, and take vector eigenvector 1 1, and lambda 1 is already given 2, and v1 is 1 1, and if we multiply these two, we will get a plus b c plus d, and formulated these two equations. Okay, similarly, if we take eigenvector v2 for corresponding value of lambda 2, we will get this equation: a plus 2b is equal to 3, c plus 2d is equal to 6, and so we will solve these these four equations for 4 unknowns. So we will get b is equal to 1 and a is equal to 1, and we subtract equation 4 from 2, we will get d is equal to 4 and c is equal to minus 2. So our final matrix is 1 1 minus 1 1 minus 2 4. We have to find the sum of a square of all the entries. So we will calculate this: 1 squared plus minus 2 squared plus 4 squared. So the final answer is 22. Okay, let us proceed with the next problem. Problem number 9. Given the function fx e की power minus 1 by x square for x greater than 0, 0 for x less than or equal to 0, which of the following statements are true? So this is MCQ question. There can be more than one options are correct. So we have to find out which options are correct. So the function to be continuous, left hand limit must be equal to right hand limit, which should be equal to value of the function at that point. So we will be talking about at x equal to 0. So at x equal to 0, right hand limit is this function at x equal to 0 plus. So this is a minus 1 by x square. This is a for minus infinity, which will be 0. So the value of right hand limit is 0, and the value of left hand limit is also 0, because in left hand limit the value of the function is already a 0, so it will be 0. So the left hand limit and right hand limit and value of the function at x equal to 0 is 0. So all the three LHL, RHL and value of the function are equal. So the function is continuous at x equal to 0. Because function is continuous, it is given that function is discontinuous at x equal to 0. So this option is incorrect. So let's talk about all remaining three options. So at x equal to 0, the derivative, which is right hand derivative, so we will calculate right hand derivative, which is 0. So and we will also calculate left hand derivative, which is also equal to 0. So the both are resulting the same value. So the function is differentiable. So the function derivative differentiable, and value of the function and the derivative of the function at x equal to 0 is 0. So because the function is differentiable, so this is also correct, and the value of the derivative at x equal to 0 is 0. So the second and fourth are correct, and this is not differentiable is incorrect. Okay, so let us proceed with the next problem. Problem number 10. Find the second order approximation for fx comma y is equal to e की power minus e की power 2y minus x in the neighborhood of 0 comma 0. So to find the second order approximation for fx comma y near the point 0 comma 0, we will use the Taylor series expansion. The Taylor series expansion of the second order for the function of two variables is given by this formula. You can find out, you can remember this formula for second derivative at least. Okay, this is an approximate formula. This comes in Taylor series expansion. So where fab is the value of a function at point a comma b, and fx and fy are the first partial derivative, and fxx and fxy and fyy are the second partial derivative. So let us calculate the derivatives for fx given function. So the first partial derivative is given as this, and second partial derivative as this. Evaluate this derivative at 0 comma 0. We will evaluate this and got this. Okay, so now substitute this value into Taylor series equation, and by substituting, so the second order approximation for our given function at 0 comma 0 is 1 minus x plus 2y half x square minus 4xy plus 4y square. Okay, so these are answer. Thank you. We will solve remaining problems in next session. Okay, thank you.